Hey, let me kick it to you right quick.
J.J. Thomson was a British chemist born in 1856 in Cheetham Hill, Manchester. He went to private schools all his life and demonstrated an interest in science at an early age. Thomson was only 14 years old when he was admitted to Owens College. His parents had planned for him to work as an apprentice engineer, but when his father died in 1873, Thomson moved on to Trinity College in 1876. This led to the beginning of his study of electrons. In 1880, he graduated, earning his BA in mathematics. A few years later, he became a professor of physics, and about 20 years later, earned his Nobel Prize.
For most of his career, he worked on various aspects of the conduction of electricity through gases. In 1897, he reported that cathode rays were negatively charged particles in motion. In 1899, he measured the charge of the particles and speculated on how they were assembled into atoms. This led to his big experiment, the cathode rays.
It all started you fussing with three guys. Your pride in the way, but your pride is the way you can around, get shot, die in a day, die every day, all over boom. When the dice game's ordinary.
Cathode rays, also known as an electron beam, are streams of electrons in vacuum tubes. J.J. Thomson discovered that to release electrons into the tube, they first must be detached from the atoms of the cathode. He decided to prove this by using a magnetic field. It took J.J. Thomson 3 experiments to fully finish his project. In his first experiment, he was to build a cathode ray tube with a metal cylinder. The cylinder would measure the small electric charges. In his second experiment, he wanted to prove that the rays carried a negative charge. By doing so, he tried to deflect them with an electric field. During this part of the experiment, he also tried to improve the quality of the project. In his third experiment, he finished up the final adjustments and proved what he needed to from the beginning.
After J.J. Thomson won his Nobel Prize, he went on to receive the Elliott-Cresson Medal in 1910, the Copley Medal in 1914, and the Franklin Medal in 1922. He was also knighted in 1908. He also discovered that the natural radioactivity of potassium, and later he discovered that hydrogen only had a single electron per atom. In 1914, he gave the Roman lecture in Oxford on the atomic theory. In 1918, he became the master of Trinity College, where he remained until his death. Thomson died on August 30th, 1940 in Cambridge, England. He is now buried at Westminster Abbey in London, England. His son went on to win the Nobel Prize in 1937 for proving the wave-like properties of electrons.
No more straight, now I'm straight. Now I get it, now I take time to think before I make mistakes, just for my family's sake. That part of me left yesterday, the heart of me is strong today. No regrets, I'm blessed to say the old me dead and gone away.